Okay, so how is everyone today? Good, I hope. All right. So, so today's the what, second? All right. No, that's not going to work. Oh, we were like zoomed all the way in. All right. Okay, now we're good to go. All right, so we've been talking about quadratics, and we're still talking about quadratics. So here we have this. So in the first place, a quadratic function is any function of the form so f of x is a multiplied by x squared plus b x plus c, and we have one requirement that a is non-zero. So we need a to be non-zero. So this form, that is to say, this form, is called the general form. General form. So that doesn't really make too much sense right now because that's an adjective, the adjective general. So if I'm going to say like this is the red pen, then you ought to like deduce the existence of maybe a pen of a different color. So there's going to be something else besides the general form, and we're going to talk about it in a minute. So that form is called the general form. 2. We said this last time, but so I'll just zoom through this bit quick. So this is the standard quadratic. The standard quadratic, its shape is thus, like that. And this point at the bottom is so important that we single it out with a name. Its name is the vertex. And what are the coordinates of the standard quadratic's vertex? 0, 0, right? So if if we take the plot, the red and the green, and then say move it over to the right 3 and then up 2, well, then the vertex would be at 3, 2. Okay, so then suppose that we make a horizontal transformation, a horizontal shift of h, and we make a vertical shift of k, then we'll have some new plot and some new equation. So if we wanted to go to the right 3, then x would become x minus 3. And if we wanted to go to the left 8, then x would become x plus 8. So generally speaking, because we're going to the right by h, that means x is going to become x minus h. And just like here where we began, we were squaring x, now we're squaring x minus h. So we also want to do the vertical shift. So that means what does y become? y minus k. Y minus k. And then notably, this particular equation, you can solve for y, and you can say y equal x minus h, square that, and then add k. So both of those are the same. The result will be that, if this is h, so that h happened to be positive, and this is k happened to be negative, then the vertex would have moved to down here. So now the vertex is at hk, and otherwise it is exactly the same. So it's a parabola that goes up like that. Okay, so I have a question. Concerning this parabola here, what is its domain? All reals. So that's asking what x's can you plug in? Well, all of them. Alternatively, you could ask the question like this. You could say, well, if I sweep some vertical lines, which ones will intersect the red? So how about that x right there? Is there an intersection with red? Yeah, up there. And then all of these have an intersection. Even the one way over here, you can't see it, but that's just because the plot, goes up really quick. They eventually intersect. So the domain is all of that. What's the range? Zero to infinity. Because now the question is that instead of considering these vertical lines, we consider horizontal lines. So like this horizontal line down here, so that particular y value, does it intersect the red? No, and neither does any of this stuff down here at all. The first intersection is going to start there at 0, and then moving up any further, there's always going to be an intersection. So 0 to infinity. What about this one? What's its domain? It's still all reals. So domain, right? And then the range is what you said. So what'll be the range? K to infinity. Right, because it's just sort of the observation that that if the parabola looks like this, its lowest point is the vertex. So that's the lowest value it can ever get. Okay. All right. So what if we start from here, and instead of doing a horizontal and a vertical shift, what if we do a what if instead of that we do a vertical scale of a? We're going to scale it by a, and a is going to be some number that's not 0. All right. So now we've got to break down the various possibilities. Is that okay? If a is like 2, that would mean that we're going to end up taking the parabola and sort of stretching it out. It's going to be tall. If a is half, then that's going to mean that we sort of like mash it like that, and it's going to be a shallow parabola. Still going to be a parabola, but shallow. And then now this is the thing that kind of hurts your mind a little bit until you get comfortable with it. What if the scale is the vertical scale is negative? Like what if the vertical scale is -3? Then what? Then it's going to be vertically flipped and then stretched by 3. Or you can do it the other way. You can say, I'll make it 3 times as tall and then turn it upside down. Or you can say, I'll turn it upside down and then make it 3 times as tall. So, like, you could imagine that, if I had some button down here, I've got buttons down here. Maybe there's some button that says flip, and then the whole thing would, read the other way. Yeah?
So, just so I'm computing this correctly, so the horizontal and the vertical shifts are going to be opposite than what you would intuitively think that it would be. However, the scaling is not. It's
No, it's still going to be opposite.
So, but you're saying half and you're squishing it.
But I'll show you in a second. I'll show you in a
Okay.
second. But here's the deal. Here's the deal. You could. So I think you're saying it's opposite from what I think because I see a subtraction.
Right.
But what I'm saying is that if you pin this down, if you wanted to move the red to the right 3 units, say like meh,
I get that, but it's actually it's not the graph itself,
It's the axis.
That's moving. I get it. That's why it's like the opposite of what I would think.
well
Because
we're
visually,
yeah
you can't necessarily see the entire plane of that you're
Yeah.
working with, so you only see what we're plotting, the graph itself. So that's why
Right.
I'm saying it's the opposite. But it seems like with the scaling that it's not.
So let's write it down.
Okay.
Let's write it down. So what I'm saying is that suppose we start with this equation, with that one, and then I say that we're going to do this. Now my question to you is, so ignoring that for a moment, and just supposing that we go from this one to that one, then A is doing something. And we want to understand that to either being done to the x's or being done to the y's. So is A doing something to the x's or is it doing something to the y's? It's doing something to the y's actually. The reason is because look at how it is originally. Notice that we're squaring x. So if we did something to x, whatever it was that we did, we have to be squaring that. So like notice that from here to here, we changed from squaring x to squaring x minus h. So the h had something to do with the x's. But this a, are we squaring the a? Or not? So the a doesn't actually have anything to do with the x's. It actually belongs with the y's. It belongs over here. And so to your specific question of opposite day versus not opposite day, that transformation would result in a parabola that's twice as tall. It would be twice as tall because you are making the world half as tall. So instead of multiplying the thing by 2, you divide the world by 2. All of it's opposite. Okay, so fine. Now, concerning A could be negative or positive. A could be negative or positive. So now let's consider those two possibilities. So A could be negative, or A could be positive. So A is negative, or A is positive. So if A is positive, that means that we're not going to do a flip. We're not going to flip it. Now, if A is more than 1, like if it's 2, that means we're making the object taller. So there's a possibility that splits like this. So we could say, well, A could be greater than 1, or A could be less than 1. All right, so let's figure this out. So if A is positive and in fact more than 1, then what we're saying is that we're going to scale that parabola, and it's going to be taller than before. So an example would be something like, an example of this would be something like, e.g., y is 2x squared. So instead of being a parabola that opens up sort of at a normal rate, it's going to open up quite quickly. So it opens up like super fast. Okay. But if instead of making a vertical scale of 2, if we make a vertical scale of half, say, then it's still going to be a parabola, but it's going to be squished down. So it's going to be a parabola, but it's going to be shallow. So both of these still go infinitely far up, but this one just goes up really quick, and this one goes up a little slower. All right. Fine. So that's what happens if we go this way. If we go this way, we're saying that we're going to flip. We're going to flip the parabola over, a vertical flip. And then after we flip it, we're either going to make it, we're either going to stretch it out or we're going to compress it. So it might be the case that a is less than -1, or it might be the case that a is more than -1. So an example of this one would be something like y is -2 multiplied by x squared. So what would that one do? Yeah, it's going to be just like that one, except flipped over. So they're both, you can see that they're both 2x squared, but this one is negative. This one is negative. So it's going to look like this. So it goes down quite rapidly. Okay. And then this one's still going to go down. So again, an example of this would be something like y is -½ x squared. So it's still going to open down, but watch. Yeah, it's going to be shallow, like this. But notice that the vertical scale doesn't move the vertex. The vertex in all cases is still at the origin. All right, so then now combining all of these together, combining all these possibilities, we have the following. Is that if we start with y is x squared, the standard parabola, and what we do with it is we do a vertical, no, I'll say horizontal first. So horizontal shift h, vertical shift k, and a vertical scale a, which isn't 0. So no, you know, if you scaled it by 0, that would just make it, that would just squish it. It would just just squish to a line, and then it wouldn't be a parabola anymore. So if we do all of that, then the equation becomes, well, so what does x become? X becomes x minus h. What does y become? Well, it'd be y minus k, like that. But we also have to account for the scale, so it's y minus k, and then all of that divided by a. So all of that. Okay. And, you know, we could solve for y. We could solve for y. So if we wanted to solve for y, what would we need to do? So I'll multiply both sides by a. So it'd be y minus k is a multiplied by x minus h squared. And then what? Add k. So it would be y is a multiplied by x minus h, square that, and add k. All right. So then now, the original parabola, this one, it had its vertex was at 0, 0. So we did a horizontal shift of h and a vertical shift of k. So where's the vertex of this one? At hk. So we moved it from 0, 0 to hk. And we also made a scale. And then qualitatively, there's sort of like the different possibilities. Was the scale positive or was it negative? Which is to say, did we flip it or did we not? And then did we squish it or did we stretch it? Okay, so then just generally speaking, I'll just do the two possibilities if A is negative or A is positive. So A is a negative value or A is a positive value. So in either case, the vertex has moved to hk. So like we're right here. But if A is negative, what's going to be true about this parabola? It's going to open down. And if A is positive, what about this one? It's going to open up. All right. So as a result, we now have the following. Is that for a parabola or a quadratic with vertex hk and scale A, is written as I'll write G. There's nothing special about that G. Then A times x minus h, square that, and then add k. This form is called standard form. So a page or two ago, we said that a different form was called the general form, and this is called the standard form. So, one of the tasks, in fact, really, in some sense, the main task that we're going to do is that we want to be able to go back and forth between this. So ax squared plus bx plus c. So that form is called the general form. And the main task that we have for ourselves is to be able to go back and forth. And there's three numbers, right? So for the general form, there's three numbers, A, B, and C. And for the standard form, there's three numbers, A, H, and K. So if I give it to you in this way, then I'm going to want you to give it to me in that way. And if I give it to you in this way, then I'm going to want you to give it to me in that way. Does everybody get the idea? Back and forth? All right. So here's an example. I could say let h of x be equal to, say, 2 multiplied by x plus 5, square that, add 7, let h be that. So then first request, is find the general form. Second request is find the vertex. Third request, the scale. Fourth request, a sketch with domain and range included. All right. So in fact, 3 of these require not 3. I'll say 2. So items 2 and 3 you can answer immediately. They require no work whatsoever when you understand the question. So for example, 3 is about as straightforward as it gets. What's the scale? It's 2. So the answer is A is equal to 2. So because the scale is 2, is it going to open down or up? Up, because 2 is positive. And is it going to be vertically stretched out or vertically compressed? It's going to be stretched out, right? Like that, twice as tall. Okay. Similarly, the vertex, you should just be able to read it off for me. So HK is what? So it's not 5, 7. It's -5, positive 7. And if that's giving you brain cramps.
No, it's okay. So anything inside the parentheses is going to be the opposite of what the sign is in the parentheses.
It's not really that. Rather it's this, is that if you write y is, oops.
Because I know the 7 and the 2, they can move over to the y, but the 5 is bound with x.
Right, yes, yes, you can think, yes, like that. So if we write this, notice that it's subtract h but add k, but if I put that k where it, in some sense, where it belongs over there, then it'll be negative, right? Yeah.
Right.
So the reason that the form looks like this, where you say subtract h but add k, is because in some sense that k belongs over there with the y. So are we all right? Okay. So then fine. How about the general form? How do we do that? So this is the standard form. How do we get it to be the general form?
Would we actually perform squaring the x plus 5?
Right. Just, algebra. Multiply it out, collect like terms. So that would be this. So that would be 2 multiplied by squaring that. That would be x squared plus 10x plus 25. And then add 7. So that would be 2x squared plus 20x. And then that'd be plus 50 and then plus 7 more. So that'd be plus 57. So that's the standard form. All right. And then we answered 2 and 3. So, 2. HK is -5, 7. 3, we said that the scale was 2. And then 4, now we want to make a sketch and include the domain and range. Okay. Well, we're not asking you to be an artist. Okay. The main thing is that it definitely needs to be the case that you have your vertex in the correct quadrant, at least. So in which quadrant is the vertex? So left or right?
Left.
And top or bottom?
Top.
Right. So it'll be there-ish. So
Quadrant 2?
it is.
Okay.
So this is you know, remembering back in the good old days. This is quadrant 1, 2, 3, and 4. So they're numbered. This is the first one, and then they are numbered counterclockwise. So -5, 7. So -5, and so if that's -5, that's maybe 7 there. And then how does it open? Down or up? Up. And it opens kind of sharply because it's 2. So it's something like that. And then it said include the domain and range. So what's the domain? All reals. And what's the range? Not quite. So remember, domain is what x values can we get, and range is what y values can we get. So if we, yeah, including 7. So 7 is the smallest thing that we can get to come out of the function. Because after all, if you look at the way it's written, okay, that's a 7, right? It just is a 7. And then we're squaring that. So whatever x plus 5 is, whether it's positive or negative, we're going to square it, and the result is going to be greater than or equal to 0, right? So the smallest this term could ever be is 0, and that term is 7. So altogether, the smallest it can be is 7. All right? Any question about this one? So this is kind of like the easy direction in the sense that comparing walking uphill versus walking downhill, walking downhill is a little easier. But you can still walk uphill. So what I mean to say is that I gave you a question where you were given the standard form, and then you had to move toward the general form. But now I'm going to do it the other way. So for example, I could say let q of x be -3 x squared, and then I don't know, plus 24 x and then plus I don't know, 11. Sounds good. So this quadratic that I gave you, is it in which form is it in? The general form, right? So as written, notice that you can't just read off what the vertex is. You can't just read it off. Okay, but nevertheless, I'm going to ask the same questions. So except the first question is now I'm going to ask for the standard form. Then I'm going to ask for the vertex. Then the scale. And then a sketch with domain and range. All right. So now only one of these things is easy. So which one of these is easy to just say right off the bat? The scale. We know the scale. It's a is equal to what? -3. So we don't know a lot, but one thing's for sure is that it opens down like a frown. Okay, fine. We can't read the vertex because it's not in that form. We don't know what h and k are. So now we have to perform work. So we have to perform work to figure out what h and k are. To that end, here's how you do it. So what I'm going to write is not the solution to the exercise. Rather, it's the idea of what you must do, and then the actual solution is short because you just need to memorize a formula. Okay. to go from general form to standard form. Well, this that parabola, if we plot it, if this is the x-axis, then that parabola, if we plot it, it opens down, right? So that's going to look something like this. If we plot it, so that'd be the plot of y is q of x. Now, if that's the horizontal axis, if this graphite is the horizontal axis, then what is its formula? What's its equation? Y equal to 0. Now, you can think of this like this is the whole plane, and what we did is we colored all the points that satisfy y equal to qx red, and we colored all the points that satisfy y equal to 0 graphite. And then are there any points that satisfy both conditions? Which is to say, are there any points that are red and graphite? Yeah, there's 2 of them. So those satisfy both conditions. Which is to say that, that they satisfy the condition that on the one hand y is q of x, and on the other hand y is also 0. So that's saying that, that what equation do those 2 points satisfy? Well, so that q of x is 0. Because if q of x is y, and y is 0, then q of x is 0. All right. Now, remember that if we knew what the vertex was, then we'd be able to answer the question, right? So then the vertex is up here with value hk. And in the end, that's what we want. We want hk. Now, if we can solve this green equation, then we can get those 2 points. And notice that h that's h right there. So if we can find those 2 points, if we can find those 2, then how can we find h? By midpoint, right? By averaging them. So h is the average of those 2 points. So h is the midpoint. Of those 2 points. Well, so let's look at that equation that we're saying that would be so great if we could solve. So the equation is negative 3x squared plus 24x plus 11 is equal to 0. And then, oh, hey, that's a quadratic equation. If only we had some kind of formula to deal with that. Oh, but we do, right? So then the quadratic formula is, in terms of letters A, B, and C, that would be negative b plus or minus the square root of b squared minus 4ac over 2a. So there's 2 solutions. So the one on the left is what you get when you take minus, when you say minus that stuff. And then the one on the right is what you get when you say plus that stuff. So what I'm saying is that the 2 solutions are negative b minus the square root of b squared minus 4ac over 2a, And the other one is negative b plus the square root of b squared minus 4ac over 2a. And they're right here and here. And the thing that we want right there is in the middle. It's h. So let's just add them up and divide by 2, because that's the midpoint formula.
Are you going to add both x's that you get?
Yeah, I'm going to add those up. So you add those up. Negative b subtract square root b squared minus 4ac over 2a. So that's the one, and then we'll add to it the other. Negative b plus the square root of b squared minus 4ac over 2a. So we add them together, and after adding them together, then we need to divide by 2 to get the midpoint. All right. Now that looks terrible, but it's not so terrible, because look at these fractions up there. They both, the denominator is 2a for both of them, right? So the denominators are the same. That means we can just go ahead and add them right now. And if we added them right now, here's a negative b, and then we're going to add another negative b, right? So how much b would be in the numerator? 2 of them, right? So negative 2b. So that'd be negative 2b. And then here's this radical thingy. So we're saying subtract the radical bit. And then we're saying add the radical bit. So what happens to it? It just cancels. It's gone. So then we have plus 0, and then over 2a. Already looking better. Still have to divide by 2. So then this would be negative 2b over 2a. And then divide that by 2. So inside of those square brackets, the 2's cancel. So we'd have negative b over a, and then over 2. And then now, performing the last division, we could say this: negative b over 2a. Not as bad as you thought it might have been, huh? So what this is this is the horizontal coordinate. This is h. The horizontal coordinate of the vertex. And from now on, this is a formula that you're expected to memorize. Negative b over 2a. But you can remember that, because if you can remember the quadratic formula right there, then h is just what happens when you just ignore the radical bit. Negative b over 2a. So none of this is work for the exercise. This is just what you're supposed to do. So to put it in standard form, the first thing that I'm going to do is try and find the vertex, actually. So the formula that now we know and you need to memorize is negative b over 2a. So for this particular exercise, for this particular one, what is b? 24. So this would be negative 24, and then divided by 2. And what's a? Negative 3. Okay, so now that's just arithmetic. So the negatives will cancel. That's 24 over 6, so that's 4. So what we're saying is the horizontal coordinate is 4. But we don't know k yet. Now, if we wanted, we could again use the quadratic formula and play this game, and we could come up with a nice formula for the for k in terms of a, b, and c. But it's a little bit tedious, and at any rate, there's a much easier way. Is that if I give you an h, if I give you any point, and I ask how high is it? If I give you an input value, I ask what's the output value. What do you do? So if we input 4, and we want to know the output, just plug it in.
Just put 4 into the original equation.
Into that. So k will be, you just take the original thing there and you plug in h. That h that we just found. So that'll be q evaluated at 4. You know, and that's calculator work, so I'll let the calculator do that. Negative 3 times 4 squared plus 24 times 4 plus 11. So I get 59. Let me make sure I did it right. Okay, 59. So therefore, we can now make an answer. We can say that therefore hk is what? 459. So to be clear, the work that's actually for this exercise is that right there. That's the work. This other stuff is, that's the formula, and this is the reason why that's the formula. So that's the work. So now we can answer number 1, in fact. How do we represent q in standard form then? So you need to know a, h, and k. Yeah, so negative 3 multiplied by x minus 4 all squared, and then plus 59. And then finally, just to make sure we don't leave it out, I wish I could have fit it all on the same page. For the sketch will look like this. So we know that the vertex is at 459. So it's like just a little bit over and then way up here. So like that. So 459 like that. And then how does it open? Down or up? Down. So it's going to look like this. Something like that. And what's the domain? All reals. And the range. Well, yeah, there you have it. So negative infinity up to and including 59. All right. So we're not going to do it today, but next time what I want you to see is that since all parabolas open down or up, and because they all either have a lowest or a highest point, so parabolas that open up have a lowest point, and parabolas that open down have a highest point, that means that if I give you some function and I say that this is profit, and I say maximize the profit, and the profit function is a quadratic, then where does the maximum occur? At the vertex. And if I give you some other completely contrived story and say where does the minimum occur, then the minimum occurs at the vertex. All right, have a nice weekend.